Hi, my name is John Kim, and I'll go over the quotient rule a little bit with you today. Make sure you know your product rule and your power rule before you actually start your quotient rule, because it's very, very important that you understand them before we start the quotient rule. So let's get started with the quotient rule. The quotient rule, the function is a quotient of two functions, f and g. F prime of x equals f prime of x divided by g of x, g prime of x. So the derivative of the function is equal to the derivative of the top divided by the derivative of the bottom. That's absolutely false. You cannot do that. Okay? And remember the product rule? Please review the product rule the way I showed you for the previous product rule information. So if you're given f of x, big F of x is equal to f times g, the derivative of that, f prime of x is equal to f prime times g plus g prime times x. That's a little bit of review for the product rule. If you're given the function as f of x is equal to f, little f over little g, then f prime of x is equal to the derivative of that. It's f prime times g minus g prime times f all over g squared. That's your derivative function. Notice that it's just like the product rule right over here, except there's a minus. F prime times g minus, instead of a plus, g prime times f all over g squared. I had a really hard time memorizing the product rule and the quotient rule at the same time, so I devised this myself when I was in high school, and I thought, oh, that's a cool way to look at it. So that's the way I use it from now on. Most books will use low d high, high minus high d low, or lower low square, or whatever. But if you memorize the product rule, this way it's a lot easier. So let's get started on some problems. I got some problems for you. Example number 1. Let's say f of x is equal to x squared over x minus 1. First thing you want to do every single time until you get used to it, label that the top function is f. F goes before g, so there's your g function. G, f, a, b, c, d, e, f, g, f comes before g, so that's the top function, and that's the bottom function. Sometimes some teachers will say derivative of 1 times 2 minus the derivative of 2 times 1. There's lots of little ways that you can memorize this, but if you memorize it this way, the product rule, it's a lot easier for you to work out. Just like the product rule, we're going to use the quotient rule. We have to find f prime first. Using the power rule, the 2 comes down, subtract 1, it's going to be just 2x. The derivative of, g, which is g prime. The derivative of x is just 1. The derivative constant is 0. And make sure you write the formula down before you start every single time. It's a really good practice to have. So f prime of x is equal to, I'm going to put my hand over this, f prime times g minus g prime times f all over g squared. Okay, and away we go, something like that. F prime is 2x times g, x minus 1, minus g prime, 1 times f, which is x squared, all over x minus 1, quantity squared. We're going to simplify that. That's going to be 2x times x. It's going to be 2x squared. 2x times negative 1 is going to be minus 2x. We're going to distribute that. Minus x squared all over x minus 1 quantity squared. That becomes 2x squared minus x squared is x squared. Adding like terms, minus 2x all over x minus 1 quantity squared. You can leave it like that, or you can factor out an x in the numerator. Factor out the x, you get x times x minus 2 all over x minus 1 quantity squared. Notice that the denominator stayed the same. Hi, Daniel.
Hi, Dad.
Okay. I'm recording right now.
Okay.
Glad you washed your face and brushed your teeth, buddy. Bye.
Bye.
Okay, sorry about that. So here we go. You factored out the x here, x minus 2, divided by x minus 1 quantity squared. That's the derivative function. Another word for the derivative function is this tangential slope function. Okay, let's do one more example. Example number 1 is done. Let's do a second example now. I'm going to use a different marker here, the bigger marker. So for example 2, the function f of x looks something like this. It's x squared minus 3x. Instead of plus 1, I'm going to put minus 3 all over 3x minus 4. Okay, it's kind of one of your problems. Kind of like one of your problems. Again, the first thing we do is we're going to label that f, label this g. It's a quotient of two functions. This happens to be a polynomial function. It's pretty simple right now. We know that the formula for f prime of x is equal to f prime times g minus g prime times f all over g squared. And so there it is. First thing we need to do is find out f prime. The derivative of that, the top function, the derivative of x squared, you should know that by now, is 2x minus 3. And g prime is equal to just 3. And if you're not familiar, please review your power rule. So f prime of x is equal to f prime 2x minus 3 times g, 3x minus 4, minus the quantity g prime, which is 3 times x squared minus 3x minus 3 all over 3x minus 4 quantity squared. At this stage, some teachers will actually say, that's good enough, whatever, box your answer. For most teachers, though, they want you to actually simplify the numerator right here. So you actually have to distribute all of this out, add like terms. So let's do that. I'm going to use big markers so you can see a little bit better. Okay. Excuse me. So f prime of x equals, we're going to distribute this out. 2x times 3x is 6x squared, minus 8x minus 9x is minus 17x, and then plus 12, minus the quantity, 3x squared minus 9x minus 9, all over 3x minus 4 quantity squared. Notice how I did put parentheses or brackets around this minus because I have to minus this whole quantity, Let's do this again. Just want to make sure. 6x squared, that's minus 8, minus 9. 8 minus, negative 8 minus 9 is negative 17. Okay, good. Plus 12. So when you take the derivative, we add like terms. F prime of x is equal to, we're going to add like terms, 6x squared minus 3x squared. It's going to be 3x squared minus 17x plus 9x is going to be minus 17 minus 9. It's going to be 8 minus 8x plus 12 plus 9 is going to be plus 21 all over 3x minus 4 quantity squared. I don't think that's factorable. I'm not really quite sure, but I'm not going to take the opportunity to factor that out, if I can factor that. But anyways, I don't think it's factorable. You can test it if you want. Just using my gut or intuition. Math is mostly a lot of gut and intuition, so use your gut. Sometimes your gut isn't good enough. Whatever. So that's the derivative. Notice again, as we stated earlier, that right here is not the derivative of the top divided by the derivative of the bottom. It's a really complicated formula. Make sure you get your product rule down before you get your product rule and your power rule down before you get your quotient rule. Okay. I'm going to do a couple of more examples for you to solidify the information. I'm going to pick some problems here. Which one am I going to use? I did a simple one. There were some other ones I wanted to do. Oh, number 15. The function looks something like this. Is equal to 1 over x plus 4 quantity squared. Okay, and we're trying to find f prime of x. So there's your f right there, little f, located on top, and there's your little g located on your bottom. And we're going to find f prime first. What's the derivative of constant? Is 0. The derivative of the bottom right there, g prime, is equal to, I have to use the power rule on this. It's going to be 2 times x plus 4 to the first power. Notice that right there, that the power came down, the inside stayed the same, and we subtract 1, or degree is going to be minus 1. Okay? So let's do the quotient rule. F prime of x is equal to, it's f prime times g minus g prime times f all over g squared. F prime is 0 times g, which is x plus 4 quantity squared, minus g prime, which is that right there, 2 parentheses x plus 4, times f, which is 1 all over x plus 4 squared. And notice something, 0 times anything, that goes away. It turns out to be 0. 0 times anything is 0. That, cancel that. And I'm going to keep this factored. On the numerator, I get negative 2 parentheses x plus 4 times 1. We don't have to put times 1 all over x plus 4. A power to a power, a square to a square is, you multiply the exponent, becomes 4. Notice there's 1 like term that's going to cancel. So it's going to be negative 2 all over x plus 4 cubed. There's your answer right there. Okay? Negative 2 all over x plus 1 cubed. I'm going to do this another way just to show you that it works out the same as the quotient rule. This is method 2. The function looks something like this. F of x is equal to 1 over x plus 4 squared. If I move this exponent to the numerator, doesn't that become x plus 4 to the minus 2 power? That's the same as this, because the exponent, when you bring it to the numerator, times 1, of course, you don't have to use the 1. It's going to be to the minus 2 power. In this case, what we're going to do is we're going to use the quotient rule. I mean, not the quotient rule, the power rule. So what's f prime of x? Bring it on down. That's the power rule. Minus 2, x plus 4. We subtract 1. Don't forget to subtract 1, okay? That's going to be negative 2 minus 1 is negative 3. Simplify that further. We get, how to get rid of the negative on the exponent? We bring it on downstairs. This factor stays in the numerator. Negative 2 all over x plus 4 to the cube. Let's see if we got the same answer. Negative 2 all over x plus 4 quantity cube. It is the same exact answer. So the question you should be asking yourself is, why don't we use the product rule in this situation? Because it's a lot easier than the quotient rule, you say. Like I said before, if you have a function that's really complicated, you have to learn to use the quotient rule. And it's going to help you do a lot of problems using the quotient rule. And so I'm going to leave that as is. And so if you have a quotient rule, you should be able to solve a lot of problems of quotient of two functions. Then you should be able to use the quotient rule. Next, what we're going to be talking about is the chain rule, the hardest one. We'll talk about that later. Good luck on your homework. Make sure you know the product rule, power rule, and the quotient rule before we start talking about the chain rule, which is a lot more difficult. Thanks. Good luck. Bye, guys.